Hello. All right. Let's get going. Problem number 181. Employees earning more than their managers. Difficulty easy. We've got another SQL one. We'll see how I do on the SQL ones this time. Table employee has an ID, a name, a salary, and a manager ID. Write a solution to find the employees who earn more than their managers. Return the result table in any order. The result format is in the following example. So you get the employee table. The output is just a list of employees. The column's called employee, and it is the name of the employee. Okay, this is pretty simple. I think I can do this pretty easily. So you're going to do select name. Let's call them E and M for employee and manager. Select E.name from the table is called employee, but we're going to join it with employee. Employee E join employee M. So the M will be the manager, or represents the manager, on E.manager ID equals M.ID. So that's the join. Then we just add a where E.salary is greater than M.salary. And I want to call it employee. So as employee. Okay, let's try submitting that. There it is. We finally did well. Yeah, I don't think you're really gonna be beating this. Even though it seems like there's a lot of variance in the runtime. Next problem. Number 182, duplicate emails. Difficulty easy. So we have a table called person with an ID and an email. Write a solution to report all the duplicate emails. Note that it's guaranteed that the email field is not null. Return the result table in any order. The result format is in the following example. It's just a list of emails, the column called email. Okay. So we know how to count. So we could do something like this. Select. There's a few ways to do this actually. But let's try to do it with the sliding window thing. Let's see if we can figure out how to do that. So select email, comma, I'm going to add a fake column that has a count. It's count of star, or I could even do ID, count of ID. Over, and then inside the over I want to say group by ID, right? Or and inside over it's called partition ID from person. I don't know if this makes sense. Okay, that's not how you do a partition. I think I have to look this up. Postgres SQL partition, or it's a window partition. Okay, partition by. I think I just was missing that. Partition by. But I'm getting a count of 1 for all of these. So how does partitioning work? It's not because I have ID and count, is it? No, you have to say what you're counting over. And ID is what I want to count over. Oh, but I don't want to partition by ID, I want to partition by email. Okay, now I have the counts for each email. Then what I want to do is, here I would want to do where the count is greater or equal to 2. But if you're doing where on a condition, or not a condition, but like a function call, it's not called where, it's called, what's the other name? It's not where, it's, Postgres where versus having. That's what it is. Having this greater than 1. Functions are not allowed in having. Oh. Or wait, do I just need to put it up here, call it as count, and then say having count greater than 1? Can I call it C? Having C greater than 1? I thought you could do this kind of thing. Well, whatever, we know how to do this kind of thing, which is to just put it in a new select. So select distinct email from this virtual table where count is greater than 1. All right, submit that. Okay. Now I'm curious if there was a way to do this without having the nested thing. If there was a way to do this condition inside the where or the having. So let's take a look at people's solutions. Oh, literally just by doing having count. I didn't even need to do the sliding window. That makes sense. Okay. Oh, because they just did the group by. Instead of doing it with a weird window, they just did it the normal way. You group by and then you filter. All right, good. Next problem. Number 183, customers who never order. Table customers has ID and name. Table orders has ID and customer ID. Write a solution to find all customers who never order anything. Return the results table in any order. So if you have these customers and these orders, the output is Henry and Max, because there's nothing in the order table for their customer ID. Okay, again, there's a lot of ways to do this. I could do a left join on orders. Why don't we start with that? Select name, left join, or wait, I have to say which table, so, and they're called customers left join orders. Where orders dot ID equals null. Syntax error. Oh, from customers left join orders. And it's not where, it's, well, yeah, it is where, but I have to say how I'm joining them. So on customers dot ID equals orders dot customer ID. So I outputted nothing when I did this. If I don't have the where orders ID equals null, what am I getting? I'm getting every name. What if I select everything from this? What does this look like? Name ID, customer ID. Yeah, and I want the null ones. Can you not do equals null? Do I have to do is null? Yeah. And it needs to be called customers. Select name as customers. And let's submit that. Okay. Yeah, there's a lot of other ways we could have done this also. But this is the simplest, I think. We could have done some other kind of counting thing. I don't think there's a reason to. Let's take a look at how others have done it. Yeah, same as what we did. All right, next problem. Another SQL one. Number 184, department highest salary. Difficulty medium. Table employees. Employee. has an ID, a name, a salary, a department ID. Table department has an ID and a name. Write a solution to find employees who have the highest salary in each of the departments. Return the results table in any order. Okay. Here we could do a sliding window, or we could do a regular group by. So let's try a regular group by, because last time we did sliding window. Select, I don't know yet, from, let's join the things together. So employee, join department, we'll just call them E and D, on E dot department ID equals D dot ID. So if we just run that, we'll just get to see the names of the departments in our result. Output, yeah, we've just got the department names in here. Here we can group by E dot department ID. And then instead of selecting star, why don't we select max of, so let's do name, comma, max of salary. And it's employee name. Or actually, I guess it's department name. But it has to be one of the things I'm grouping by. So why don't we group by department, or why don't you print me the department ID? Which is just D.ID. So group by D.ID. So is this right? The max in 1 should be 90,000. The max in 2 should be 80,000. So I'm getting the right answer. But what does it want me to say? It wants me to say department, employee, salary. The problem is I have to put these things in my group by if I want to select them. Because I can't just do d.name, because it's going to say you'd have to group by name. But if I group by name, then if the department has a duplicate name, we'll get the wrong answer. Oh, they also want the employee name. So now I am not as sure about how to do this. I could do the sliding window thing again. I'm sure there's some simple way to do the group by, because I'm really close to the answer here. What am I getting as my answer? I'm getting the salary I'm getting the salary and the department ID. So I could do this, which is silly, but select like once I have them, I could select from the respective tables with those IDs. I think, like, can I even do that? Can you do a select of a select? Select name from department where from department D, or just from department where ID equals there's no where because there's no join, but there is a where because I wanted the one that has this ID. Call this D2 where ID equals D2.ID. From this. Does this even work? Oh, more than one row. So limit 1. It gave the same name twice. How did it do that? Okay, there we go. If I gave stuff proper names, then it works. Okay, so like this is horrible, and I say that a lot, but our first column, and this is going to be called as department, is get the name from this thing and find what its name is. No, this is too horrible. Let's just do this and then join it with something else. So select name. What do we need? We want department. So select department d.name e.name max as salary from this joined on the department name or on department. So department. Let's get rid of e.name for a second just because that's going to make it harder. If there's a join, I have to say on. So on this thing, which I'm going to call T, and I've already got a D, but maybe the scoping will make this unambiguous. D dot ID equals T dot ID. Okay, I've got the name and the salary. The name is supposed to be department. The max is supposed to be called salary. So we've got department, we've got salary. Now we just need employee. So we can join this again. Join employee E. On T equals this, or wait, does each one get its own on? I think it does. So here this would be on E dot salary equals max. Oh, okay. And then E dot salary. Department salary salary. No, this should be E dot name. No, it should be employee. Okay, as employee. Okay, so you got 1, 2, 3 columns. From this table, join that table, join that table. Okay, submit. Wrong answer. I have duplicates. That makes sense. I can just throw a distinct on there though, right? Yeah. Submit. Still the wrong answer. Oh, distinct. Actually, what are you supposed to say if there's more than one? Maybe it doesn't matter. Can I say it's distinct on department ID? How do you do that? Postgres distinct on. Oh, you just say on. So distinct on department ID. Nope, you don't just do that. How does it work? Distinct. So why isn't this working? Select distinct on. Isn't that what I'm doing? Select distinct on thing. Does it need to be in parentheses? Oh, it does. Okay. Still not getting the right answer. Oh, wait, it did expect the duplicates. So I shouldn't have the distinct. But I'm not getting the right salaries. Oh. Not just that the salary matches, but also the employee dot department ID equals d dot ID. There we go. Submit. Okay. I'm sure you can do better than this. This is like it's weird that I had to do the nested thing, that I had to figure out the grouped version and then join that back with everything else. So how did others do it? This does not look simpler than mine with the dense ranking. I don't think that's better. This looks the same as mine, but I had to do 2 joins on the outside for some reason. Well, okay, this is interesting. They grouped by department name, which you shouldn't do because then there could be a mistake if 2 departments have the same name but different IDs. But let's say you do that. How do they... Oh, because of the in. So this is the same as what I did, but they're skipping a step because they're grouping by department name instead of ID. And then this in is a way to... is a different way to do the joining. This doesn't seem like it should be better though. Window function, I'm curious about this. Well, it's the ranking thing again. Okay, then I think we did okay, actually. This is what we're doing. No, they've got the in, so this avoids one of the joins by doing an in. What is CTE? Everyone's talking about CTE solutions. Postgres CTE. Common table expression is a named temporary result that you introduce with a with. Were they doing that? No. But is there one that works well with the CTE? Everyone's doing the in thing. I guess I don't know why that should be better than what I'm doing. CTE approach. Maybe we'll see what CTE... Okay, they've got with. Oh, and then it's the ranking stuff, which I think is harder to understand than what I did, for sure. All right, let's move on to the next one. And we've got a hard SQL question, the first one. Number 185, department top 3 salaries, difficulty hard. Table employee with ID, name, salary, and department ID. Table department with ID and name. A company's executives are interested in seeing who earns the most money in each of the company's departments. A high earner in a department is an employee who has a salary in the top 3 unique salaries for that department. Write a solution to find the employees who are high earners in each of the departments. Return the result table in any order. The result format is in the following example. So here's employee, here's department. They want you to output department, employee, salary, and they want... Wait, why was there's 4 from IT? Is that because there was a tie? Okay. which makes me think we need a dense rank in here. That's what I've learned from the previous SQL questions. So select star dense rank over from employee. And I don't know the syntax for this stuff yet, so let's start by not specifying anything and seeing what that gives me. So everything's tied for first, probably because I didn't say what you're supposed to rank. So why don't we rank salary? Within group is required for ordered set aggregate dense rank. I'm not sure what that means, but the thing I know I need to do is partition by department ID. Is it, you don't say by, you just partition department ID? Or that's in the over, actually. That goes in the over. Is this a by? Okay. We're making progress. We have a dense rank in the output. Everything is tied for first. But we still haven't said how to rank. Well, I guess I thought it was going to do 1, 2, 3, 1, 2, 3. Like, is that not what rank would do? No. What if I did row number? Yeah, that does 1, 2, 3, 4, 5, 1, 2. So I thought, and there's no such thing as dense row number, right? Because you just go in order. Okay. How do I say what to rank by? I think we have to look up dense rank. Postgres dense rank. Yeah, give me an introduction to this feature. Well, this sucks. I don't want to read this because this is the same problem that we're solving. I just want to see an example of syntax. Do I need an order by? Probably. Order by salary. It's not called rank number, it's called dense rank. One, two, three, three, four, 1, 2. That may be what we're looking for. Let's order descending so that 1, 2, and 3 are the ones we're looking for. 1, 2, 2, 3. Okay. Then we do a having dense rank less than 3 to filter it. No, I think the way you do that is you just take this and you put that here. No, you can't do functions inside having. I haven't figured out how having works. I thought that's what it was for, but And I know you can't do where because that's going to say that the thing doesn't exist. So I guess we just use this as an inner virtual table and select from it. So what are the things we actually care about? Department, employee, salary. So d.name, department name, e.name, and I'll just call it as department. E.name as employee. E.salary as salary. From this table, we're going to join it with both the employee table. This is going to be on employee E. This is going to be, and this table is going to be called, actually this is the employee table already. So as E. Join it on the department table. On e.department ID equals d.id. Where dense rank is less than 3, less than or equal to 3. Submit. Okay. So how do you do better than this? You can probably do this all in one level. I just didn't know how to do the stuff on the dense rank without putting it inside a I don't even know what you call it, a virtual table that we have to rejoin with department. But I ended up slower than I thought. Never mind, it's all variance, beats 96%. Okay, let's look at solutions. Subquery in the where clause. Where salary in, and then you have a limit 3 query. Nice. Okay, that is one way to do it. Here's the dense rank way. Oh, this seems more complicated. This isn't even using. Where's the dense rank in here? There's no dense rank in here. Oh, it's the without dense rank. Okay, yeah. Yeah, this is like the answer we did to one of the previous ones where you just have queries limited by 3 and then actually, I don't know. This is kind of hard to read. I don't know what that one's doing. Does anyone have something we didn't think of? Count between 1 and 3. What are they counting? Count is the dense rank. Yeah, count is the dense rank. So this is the same thing we did, but they did count between 1 and 3 instead of dense rank less than 3. Cool. Oh, second solution. This is exactly what we did. Department, name, salary. From I guess this is a good way to use with, just because it's hard to read this in the middle of our query. So from, they called it R, we called it E, join department. Yeah, this is exactly what we did. Cool. And that's all for today. Thanks for watching.